So, welcome everyone. Today we are going to talk about a physical units library that I was reading or rewriting from scratch in the entire last year. 2 weeks ago, as I mentioned yesterday on the Lightning Talks, I was able to merge my branch to the mainline, which for me personally was a great achievement. I celebrated with the wine and so on in Varna. And finally, I can actually start talking about this and can provide also Lightning Talk series that you've seen yesterday, and another one is coming today as well. My name is Mateusz Pusz. I'm the Chief Software Engineer in EPAM Systems, and also I'm the trainer and consultant for C++. So today we are going to talk about physical quantities, units, but also about C++ language, templates, and how to make compilers sweat. First, I'm going to briefly describe what we had before and basically what is on the market right now in entire C++ language and also in other languages, because I also were analyzing C#, Java, Python, and other languages as well to find out how they use and how they treat similar things in their domains. So, what were the issues with the previous design of the library? We are going to talk about the downcasting facility, issues that were not able to address with the current framework and with the framework of other libraries, why UDLs are not a good solution, because this is actually a common question that I'm asked by the users, and basically how it was, what was the feeling of standardizing stuff or defining stuff as a system in this library or others. So basically those are really verbose. Even in my solution that was meant to be terse, it was quite verbose as well. So what was the downcasting facility? Downcasting facility, I think it's still quite innovative idea, really great one. In case you want actually the solution, I spoke about this on many conferences. I will not repeat how it works here because, well, it is like half an hour of presenting things. I will show you what are the results of it and why it's not a good solution for this domain, but for other domains it may be a perfectly fine technique to use in your code. So, assuming we have this simple code, we have a function that calculates average speed that takes length argument, time argument, and produces speed, right, by division one by another. And we are printing this here as a speed. Of course, when you initialize it this way with 140 kilometers and 2 hours, right, you expect something like 70 kilometers per hour being printed, and of course this is the result, right? However, this may seem obvious, but actually when you go to the compiler errors or to the debugger, this is what you will see. You will see that actually from this division of length by time, the framework was able to find nicely named types for dimension speed, kilometer per hour, for you, right? Those are the types defined by the user, and the framework, by doing some arithmetics, was able to find those types and use them in the final resulting type provided here as a return of this function. And it was really awesome because it made all of the compiler errors so easy and nice to read. What downcasting facility is? It introduces a one-to-one relationship between long specialization of a template type and nicely named user short type, right? So if you have something like this is a type produced by the framework and also used by the user to specify this element. This is the one provided by the user as a strong type for that. So the framework knows about this type. So whenever this type is being generated, it is being replaced with the user provided type thanks to this CRTP pattern here when you provide this type to underlying framework. So it knows when you see something long like this one, convert it to this type, and this is what is provided. So this was the facility. It provided a really nice user experience for the library, but there are some issues. So what are the issues? First of all, in the physical units domain, it turned out that there is no one-to-one relationships between things, but there is at least n-to-1 relationship between different entities. So, for example, energy and torque have exactly the same dimensional equation. So you have to choose one for the long equation, and the other one is impossible to actually express, which was quite problematic for me. Also for the unit, frequency is the inversion of time, right? The same of activity, modulation rate, all of them have exactly the same dimension. In terms of units, well, hertz is 1 per second, becquerel is 1 per second, baud is 1 per second, and also 1 per second is a unit by itself. Sometimes you want to express things being 1 per second, like number of cars passing the highway. Number of cars per second, right? Not hertz, right? In case actually both definitions were found at compile time, we got compile time error because compiler said, well, you are like redefining stuff. I cannot have two definitions that differ with the nicely user provided name for the same long type. And this was some limitation, so we tried to work around this with some hacks. We invented something like an alias unit, saying, well, bot is nearly like a hertz, but it has nicely named name bot and a different symbol. But the outcome of this was whenever the library by itself found something that was 1 per second, it converted this to hertz, and this was the result. In case you wanted to have to see bot in the output of the text, for example, you should convert this manually to bot if the framework was not doing this by yourself, by itself, right? You have to do it for you by hand. And also, for example, modulation rate was stated just as an alias type for frequency. So wherever you've seen a compiler error, you've seen frequency because this is what compiler was using under the hood. So those were the limitations, right? And also it was impossible to actually print 1 per second at all because compiler always says, well, 1 per second is always hertz. So I will not allow you to print 1 per second at all because it's always hertz. So we started to look for some additional and some other solutions for this problem. However, this is not only that. For example, if you have this code, as you've seen before, right? If you will use tool like include what you use, the tool will say you are not using any unit from the speed header, because this concept is not there. This concept is provided in dimension speed, not in the unit. So it suggests, okay, get rid of the header file and replace it with something that you actually use. But with this, you actually removed all of those definitions, kilometer per hour, from the translation unit. The things that you are not using explicitly in your code, but the things that framework has to know in order to provide a nicely named result. So as framework doesn't know about it, this is the type you get. And this is the output in the text you get. It's quite not that user-friendly anymore, right? Another point that can happen is that if you put the same code in the header file, actually it was pointed by Lisa at one of the cppcon, I think, discussions we had, right? Is that in case you have one translation unit that will provide the header correctly, you will end up with nicely named type as an output and the correct unit being printed. If the same translation unit or similar one will not use this header file, it will end up with this long type. So the same function specified in the header file will have two different definitions in two different translation units, which is an one definition rule violation. And language does not like those, right? And linkers as well. So you have to be consistent. You have to provide the same set of headers in every translation unit, which may be problematic for everyone. Right? Also, some users wanted to provide something like device-specific units. Even if they were the same, they wanted to have a different name for that, saying this is the unit for this device, this is the unit for this another device. In case both are hertz, well, again, it sucks. And, well, it didn't work with NTTPs because it was about types, not about the values. So it was somehow limiting. Another thing that you should not talking anymore about the downcasting facility was that if you had something that was not predefined by the user, you ended up with something that was quite long. It's still quite short compared to other libraries. If you know how Boost library, for example, works, the first line of the Boost error doesn't fit on a slide. Right? So this is still quite terse, but it was terse in the beginning, but then we started to introduce things like conversions from the radian to degrees, which requires pi number in a conversion, so something irrational. We started to add those magnitudes, which makes the type longer. And this is inconvenient somehow to read and understand. So also we are looking for some alternatives. And this is common for every domain because most of the frameworks we have right now do not provide good compile time errors for types generated by the framework itself. Another thing that I had as an issue is that we decided to have derived dimensions to be closely connected to units they are measured with. And with this, I had concepts taking type or concepts taking template. And then I had to provide two different concepts names because we cannot provide either a type or a template as a parameter to the same class template, right? Hopefully, the P1985, the proposal that I'm actually championing for C++26, will allow us to have so-called universal template parameter kind, which will bind to anything, to types, values, and templates, and then it will be possible to write only one concept for that. But until that, I had to provide two names for different concepts, doing exactly the same, but just taking different arguments for analysis. And also, it meant that standalone dimensional analysis was not possible because I always had to specify some unit. And in standalone dimensional analysis, I don't want to talk about units. I just want to talk about dimensions. Another really big problem, and this actually is about every library on the market nearly right now, is that we tend to use types for units, for quantities, like this one. For angular momentum, we are using a unit called kilogram meter square per second. A long thing to type, maybe. This is first thing. Second thing is that now consider that you want to provide all of these scaled versions for your users to make them happy. How many variations of that type you would like to provide in order to make sure that no one will complain that this favorite unit of this person will not be there, right? I can imagine someone trying to do picograms, kilometers per nanosecond. Provide this one, and 300 others, right? For only this one quantity. It doesn't scale, it doesn't compose, which is a big issue, and this actually is how it's done in all libraries in the market, nearly probably right now, right? Another thing, what should be the result of this equation? If you want to add Hertz plus bot, bot is to measure modulation rate in IT domain. Hertz is about some periodic activity. You could also add some other units here, like becquerel, that is used in a totally different domain. All of them are 1 per second. What should be the result? What should be printed here, right? My library printed 2 Hertz at this point, which probably is not correct. Another point that was actually an issue that we found out and tried to resolve in the version 2 is that we had a notion of quantity kind. So there's not just length. You may have width, height, altitude, radius, many different kinds of length. And you would like to have treat them as strong types, so you cannot replace them, for example, in the argument list of a function, right? So I defined a kind for length, I defined kind for width, and I want to make them strong types. Then I create strong types for them. I call this is not a quantity, but quantity kind, taking the length kind tag type that make them strong types separate from each other. And this is fine, but they do not compose. If you want to create horizontal area from those two, it was impossible to do this automatically by the framework. You should provide, and then alternatively you had to provide additional tag stating that this tag can be converted from those, a lot of things. Framework by itself was not able to say, well, this is horizontal length, width and length, so it is horizontal area when you multiply them. Didn't work, and doesn't work in any other library on the market right now, according to my understanding. And finally, why user-defined literals are not a good solution to express or create quantities, right? First of all, user-defined literals are only about compile time known values. And if you think about your project, how many compile time known values you have in your production code besides unit tests? Because of unit tests, of course, this is really useful because unit tests are all about predefined values. But in the framework, in the production logic, you don't have many compile time known values. Maybe some constants like G or C, right? So speed of light and the gravity constant. But other than that, you are working on variables. And variables cannot work with UDLs. So they have limited use case, limited usage in your framework. So you're providing a lot of definitions that are really not that useful at all in your framework, but really useful for unit testing, right? Another thing is that when you see code like this one, this is Chrono, even not my library, this is Chrono, so part of the standard for more than 10 years right now. What do you think? What is the underlying representation type for D1 and D2? Any ideas? Double could be for the second one, but actually it's not the correct answer. What they do, they always provide the longest possible representation number for integral and floating point number. So if you put those, you will end up with int 6040 and long double in your code. That's a lot of space, especially for example, an embedded project. And moreover, you may have 20 quantities defined just for short because are in the embedded domain. I add one literal to it, and immediately all of the calculation starts to be as wide as the longest element of arithmetics. This is how math works in C++ language, right? Adding, I don't know, short, plus long, long will be long, long. So if you use at least one UDL in your equation, now the quantity type explodes to be really huge. So you have no control over that. Of course, you can do some tricks with template parameters, find out what is the value at compile time and find the presentation type that fits to this value. But that's even harder to specify and do. Also, it turned out that many compilers right now provide non-standard extensions for specific literals. All of those names are already reserved by the compilers to do something, other things, right? And those are, of course, names of the units as well. So it may be problematic if you want to actually implement those. That's why we invented this Q prefix for the standardization needs, so it doesn't collide with what is already on the market by other compilers' extensions. Another thing, if you are having two systems, SI and CGS. CGS is centimeter gram second system, and in both there is a second. If you will include UDLs for both, how do you say I want to create 1 second? Which second? SI or CGS, right? There is no way to provide, to disambiguate an UDL with a namespace because this is how language works. You cannot provide namespace name before UDL, right? And they don't compose, again the same unit for angular momentum. How many UDLs you have to specify to make all of the users happy? The same issue, right? And it's even harder because every specification requires two definitions for integral and for floating point number. So this is that number multiplied by 2. That's why we don't use UDLs. Maybe they work for Chrono, but they don't work correctly for physical quantities libraries. And again, most of the products on the market actually try to use them because this is what Chrono does. But I don't think it's a good solution. Another issue that we had is that we couldn't find the best way to actually find the way to create a quantity. We had like 4 different ways to do it, and there was always some trade-off between those things. There was not one single winner. Actually, on CPPCon 2021, I provided a talk called Software Engineering is about trade-offs, when I described this problem and asked the audience to choose the best one. Oh, actually I don't know why I don't see this one, because I see the graph on my screen, but not there. Sorry for that. There was a graph with the answers from the audience. I don't know why the screen doesn't present the image right now. Maybe it's because of the OBS, unfortunately. I don't know. Sorry. All right. So also, even though the library the definitions in my library were really terse comparing to others, because for example we are not using any predefined macros to specify things, because typically libraries use macros that introduce like 5 or 6 different definitions per one quantity, a unit, and the text being printed, and so on. We had only one line per thing. Still, it was quite verbose to specify all of those unit types, and then some specific dimensions and literals for them. All of this is not needed in the version 2 of the framework. So all of those were the issues that we tried to address, and now we are going to talk about the solution. The solution is still work in progress. I'm still working on this. It was, as I said, merged on the mainline 2 weeks ago. Still, for example, I'm working on documentation. Still, we have some features to be implemented, a lot of ideas. So we are looking for feedback and for users, of course, to provide us some ideas and feedback on how it works for you guys. One question may be, why V2 if we never actually even released version 1.0 in our library, right? The last release that we had was 0.80, and we are switching to V2 right now to not provide impression that this is like an evolutionary upgrade of the previous version, because 1.0 typically is just stable release of what you had in the pre-release, right? I could either start a new repository like Eric, range v3 or units v2, or upgrade significantly the number to say there's nothing in common with the previous code. Because we are breaking everything. We are breaking abstractions, we are breaking types, we are breaking namespaces, we are breaking header files and their layout in the file system. Everything is a huge breaking change for my users, and I'm really sorry for that if you are my user already, because this library will not compile right away in your code. But hopefully you will find a lot of benefits here to actually upgrade to a new design. For example, let's see even this syntax here, quantity of ISQ speed meter per second. Probably you will see that there's something novel here, right? No one ever used similar approach to express quantities, and I think this is really supreme one to use. Right. So this library is really putting a lot of pressure on the compilers. For now, I only was able to make it compile on GCC 12.2 or later, and I'm sorry for that. Clang and MSVC are way behind, even though this is only C++20 library. 3 years after C++20, still compilers are not up to date, are not fully conformant to the specification, and they do not work. Of course, I will be working on workarounds, trying to port this library to older compilers, but well, at some point probably I will have to give up. I cannot like change entire design just to fit the compiler needs, right? So in case you are a compiler vendor and would like to actually improve the implementation of your compiler, please let us know. Let's work together to improve your implementation, and then maybe we'll solve those issues earlier, right? Because as I said, I will look for workarounds, but I'm not hesitating to. I will not change the entire design just to make it simpler for compilers to make it work, because my target is actually not to have backward compatibility. I'm trying to experiment the best possible interfaces for possible future standardization, right? So right now we are possibly targeting 29. 26, of course, is out of scope right now, but possibly 29 is possible. So, well, if it succeeds, of course, it will be fine. If not, well, I will not die for it, right? It's not my ultimate goal to be in the standard, but if possible, I want to keep this door open, and I want to use the latest techniques, the latest possible interfaces to make it the most user-friendly for you as a user, right? So first of all, you will find a lot of new style of definitions in the library. In the new library, users always work with objects with values rather than types. But observe the types in the error messages in the debugger. That's why in the library, to improve the compiler readability, we use the same identifier for the type and for the object. This is quite novel. Not everyone uses this, but this is allowed by the standard. To have the type and an object of the same name. This makes the users easier to relate the code they write, like this one, right, to the compiler error message. You're providing the same things, but in this case, here you observe the type, here you observe the value. The idea here is to make users forget, actually, or even not care what is type or a value. It just should be easy to understand. And I hope it is, right? And notice how nice the type is as a derived one provided by the framework here. Meter per second is written as derived unit meter per second. This is how the new framework does it for you. So expression templates used extensively in the library make these types much easier to reason about and read. And generally, it's not even about my library, but generally we talk that physical quantity libraries enforce correct code, right? For example, if you type things like this, they will divide things and verify if it's actually speed, if you don't have any errors in the equation here, right? Will convert units. All of those are really important things about the libraries, right? We use them to provide strong types, to provide compile time safety to our code. But immediately, all of the libraries, when we provide a quite different example, provide only such an user interface for the user. Do you see some possible issues in this implementation? Right? We have a box. Box has an area being a base and a height. And then you provide the dimensions, length, length, length. And then you initialize it, 2 meters, 3 meters, 1 meters. What can go wrong? Right? And none of the libraries on the market can handle this correctly right now. Maybe with quantity kinds and tag types like I tried before. There's one more library trying this as well, but even the author says, well, this doesn't work. Don't use it, it doesn't scale. There are plenty of errors connected and plenty of casts needed in order to make it work later on. But I try to address this. I try to address this in the version 2. So those are so-called quantity kinds, and I'm going to talk about them in a moment. So in order to implement that, actually I had to do some discoveries. How many of you have heard about SI system? Hands up. For the audience online, nearly everyone. How many of you have heard about ISQ, International System of Quantities? I see 3 hands. And this is, yes, this is exactly how it's generally in the industry, right? ISQ is so-called system of quantities. It's a set of quantities together with a set of equations relating them without talking about units, without talking about values, just how different quantities relate to each other. And it turns out that there is actually a standard for them, standard provided by ISO. It's called International System of Quantities, ISQ. It's standardized by ISO 80,000 and provides, I don't know, a few hundred of quantities and how they relate to each other. They base on the 7 base quantities, right? Length, mass, time, electric current, thermodynamic temperature, amount of substance, luminous intensity. So the things that should be familiar to you, because this is what SI uses for units, right? But it talks only about quantities. And then SI is explicitly stated to be based on the International System of Quantities. So SI doesn't define length, time, or whatever. This is defined in ISQ. SI only provides units for those quantities. And this is how you should think about it. System of units is based on specific system of quantities, and those are, let's say, a bit orthogonal. Right? Of course, one is depending on another, but they provide totally different things on totally different items, entities, and so on. My library is probably the first one on the market in any programming language, because I was looking in Python, I was looking in C#, in Java, in C++, of course, and no one seems to model this, at least in open source, because I don't know what people have closed source in their companies, right? So if something doesn't look right, or odd, or could be improved, please let me know, right? Because this is something that I had to invent during the last half year or more, right? But I think that actually what I ended up with, I'm quite happy with that, and I will try to explain you some rules about it. In ISQ, we are talking about base dimensions, and this is how we define those base dimensions for 7 quantities. I'm not expecting you to read everything here. I just want you to show how terse it is, how easy it is to understand each line, right? And again, we have the same identifiers for type and for identifier, right? For direct dimensions, you never have to specify them explicitly. The framework will do it for you. There is no such thing like a dimension of speed. No one never defines a dimension of speed in any official documentation. All of the libraries say there is dimension speed, but there is not such thing in the physics. There is length per time, LT minus 1. There is nothing such called as dimension speed, right? Speed has some dimension, but it's not a dimension speed. Also notice how awesome non-type parameter usage is in our language. I will show this many times to you today, right? You can use text to initialize templates. You can even use custom types that provide you Unicode or ASCII text if needed for different representation types. And it turns out that dimension is not enough to specify all of the properties of a quantity, right? We spoke already about things like frequency versus modulation rate. The same dimension, different properties. But there is more, right? We have different kinds, frequency, modulation rate, but we have also quantities of the same kind. Length, width, altitude, distance, radius, wavelength, position vector. All of them are dimension length, but are used to measure totally different things. And they should be separate in the type system as well. Another thing, quantities may have different character. There are scalar quantities, but there are also vectors and tensors. Most of the libraries on the market ignore that. The only one that I actually know works with correct expressions here is Pint in Python. In C++, I don't think there is any library that actually works correctly that can actually have operations like dot product, vector product for quantities. But this actually you have to provide if you want to support vector quantities correctly. And those cannot be multiplied or divided, even though every library in C++ actually tries to do it and then crash. And also some quantities, for example, are defined as non-negative. Right now, of course, this comes to GSL macros, but hopefully contracts are coming soon, and we could use contracts to express that as well. This is how ISQ defines the quantities of length. You have width, thickness, diameter, radius. Notice that it is a hierarchy of types with some dependencies, and those after comma are let's say, aliases for the same name, but according to ISQ. So in theory, height, depth, altitude are the same by the ISQ system. And this is what you're dealing with when you're talking about quantities of the same kind. And then you have to model that. A quantity being the root for such type just takes the dimension. And then if you're creating a leaf, you specify what is your root or the branch for the leaf. Right? And if you're creating an alias, you are just creating an object of different name for the same thing, because this is just an alias. This is how you specify that. And then you have all of those definitions, all of this tree on this slide. Again, I don't expect you to read everything. I just want you to show how terse it is and how easy to understand each line here is. Right? Notice that I can add things like quantity character vector here to specify this is a vector quantity. And for the time, similar things. With that, I was able to remove the abstractions for quantity kind and quantity point kind because they are not needed anymore. I'm just using proper quantity types rather than having special types for that. And how the conversions work here. I have 3 levels of conversions in the library: implicit, explicit, and cast. And let's assume the simple tree like this one. And then width is not a length, width is not a height. Those are different, right? But every width can be converted to length because every width is some kind of length, right? So it's implicitly convertible. Not every length will be width. So you cannot implicitly convert length to width, but you can do it explicitly, saying this length is a width, right? Height cannot be converted to width. They are totally separate branches, right? They do not have nothing in common. So they are not implicitly convertible, they are not explicitly convertible, but they cannot be casted. They can be casted with special quantity cast, really expressive long name to show you're doing something unsafe, but sometimes needed. I will show you examples for that in a moment. And of course, time and length, well, those are totally different quantities. They cannot be converted in any way, even with an explicit cast, because it will be simply wrong, right? They have different dimension, cannot be converted at all. Also, if you want to add them, what should be the result of adding width and width? Of course, it will be width. But if you want to add thickness and width, you end up with width. Or if you want to add thickness and height, you end up with length. And this is what ISQ says, right? So you have like a box for the Christmas gift. If you want to find what should be the length of a paper to wrap it, what you are doing, 2 times width, 2 times height, and this is the length, right, of the paper. So for those cases, it is useful to actually add those quantities and have a result of length, right? Having result of being either thickness or height would be incorrect. But length is a valid choice here and actually works really nice without having to have any explicit casts. The rest quantities are created by the same quantity spec type template, a class template here, and you provide the equation, either power of length for area and volume, right? Or for speed, length by time, and so on. Or 1 per period duration for frequency. Again, NTTPs are awesome. They allow us to specify those equations with user-readable and easy-to-express code in a class template definition. This is way better if you're familiar with things like ratio divide, ratio multiply, ratio equal. You know what I mean, right? This is so much better. And those also allows us to do this pure dimensional analysis. I can check the dimension of area is that, right? Speed dimension is that, and so on. So not talking about units, about representation types, values, just talking about quantities and their dimensions. I can do all of the logic as well if this is what you desire in your program. You can even use only that part and just not use any other thing to provide dimensional analysis to your code base and just maybe build on top of it your own types. When talking about derived quantities, well, this is quite tricky because not every quantity has an equation provided. For example, mechanical energy do not have any equation provided by the standard. They just say this is a special kind of energy, right? And only, for example, kinetic energy has one, but potential doesn't, because potential has 2 different kinds of potential. There is gravitational potential energy and spring or whatever potential energy as well, right? Elastic or something like this. That's about springs. And they have their own equations. So only those equations are provided for 2 of them, but there's plenty of them defined in the ISQ. So we have to create one thing, the tree. Second one is to provide those constraining equations somehow So I can say, well, this is maybe less mass length squared time squared, but this is probably not. This is something more special. So I should not be able to create it implicitly from that. And also here, I can do it implicitly from that equation, but possibly not from this one. So this is how you specify this, right? This is, again, a really simple thing. The first attribute provides you the layout in the tree. The second one provides this constraining equation. And again, concepts are awesome. With concepts, I am able to use the same name for the same class template, even though they are different types of parameters, different kinds of parameters. I can provide specialization with concepts, and users do not have to remember what is the name for specific thing, like constraining quantity spec, for example. It should be provided before as a different type, because it takes different number of arguments than the others. The same name can be used easily with concepts. Right, so if I'm having this, I already mentioned this on the tree, but this is how you do it in the code. If I have this quantity, this is not an energy, but it's implicitly convertible to energy, right? And the other one with the speed is implicitly convertible to kinetic energy. If you want to do it for another thing like mechanical energy, you need an explicit cast, not an implicit one. And user can always easily extend existing system of units or quantities by themselves by just providing single line by themselves. Like user can provide horizontal length to be a length in a horizontal dimension with this simple line, and then define something like horizontal area using saying this is some kind of area, right? And this is the equation for it. And then everything works as should, right? Horizontal length is a length, but not every length is a horizontal length. Horizontal area is an area, but not vice versa, right? Length by length is an area, horizontal length by width is a horizontal area, so they are implicitly convertible. But horizontal length and width is some kind of area, so it works, because this is still some kind of area. But length times length, well, not every length by length will be in horizontal plane. So it's not implicitly convertible. So all of the logic just works as you would intend in this library. I spent a lot of time actually trying to make it right, but I hope it actually has sense. Coming back to this equation. 1 Hertz plus 1 becquerel plus 1 baud. Hertz is a unit of frequency, becquerel is a unit of activity, baud is unit of modulation rate. Right? All of them are quantities of dimension time minus 1. Let's see what other libraries on the market claim about this. So if I do this in Boost, I cannot use baud because they do not model this one, but at least those two is enough to check what it is. The region is Hertz. If you're wondering that maybe Boost always takes the left-hand side unit, it doesn't. It's again Hertz. And when I try with Nichols unit, really great and powerful library, the result is a bit better. It's 1 per second. So at least not Hertz, right? Some common unit is found. It's a better solution, but still it can be added. So let's look at other programming languages. In Python, they have all of the 3 units. It's 3 Hertz. And now my favorite one, Java. This arithmetic is huge, right? Would you like to write things like that in C++? But you may laugh, but see this compiler error. Compiler error that I really would love to see in C++. And this is end of the error. There's no like 100 line following the error, like in our case, right? It says explicitly, unresolved compilation problem. The method add quantity frequency in the type comparable quantity frequency is not applicable for the arguments comparable quantity radioactivity. That's the entire error message you see, and nothing more. And this is so expressive. This is something that you probably will never be able to achieve in C++, but I'm trying my best to actually provide at least first line being similar to this one, because, well, there always is a concept line like error message providing 100 lines more, right? So how to actually make it work? In order to make it work, we have to introduce a new abstraction called quantity kinds. And ISO 80000 says explicitly that quantities may be grouped together into categories of quantities that are mutually comparable. Mutually comparable quantities are called quantities of the same kind. So if you can compare them, they are of the same kind. And then explicitly says 2 or more quantities cannot be added or subtracted unless they are of the same kind. So only those can be added, subtracted, right? And it says explicitly, quantities of the same kind within a given system of quantities have the same quantity dimension, and quantities of the same dimension are not necessarily of the same kind, right? Frequency and modulation rate have the same dimension, but they are not of the same kind. And those are actually all of the quantities that I actually found for now in the ISQ system that has the dimension of t minus 1. There's not only those three that I've mentioned, there are many more, like angular velocity, frequency, rotational frequency, angular frequency, lots more of quantities with the same dimension of time minus 1. Specified as separate quantities. You don't want to mix them, you don't want to add them. But right now, any library in any programming language don't care. Maybe besides Java, right? In Java, this library was providing compile time errors. Right? But they do not say that those are like separate kinds or whatsoever, it just doesn't add. And this is something that we want to model as well. To model that, I introduced a kind of modifier. You provide a quantity spec and say this is a kind of this quantity spec. It denotes a family of quantities belonging to the same kind, which means that such a quantity represents any quantity from the tree. If I say kind of length, I mean any of those things in the length tree. Right? So you can obtain this by doing get kind on a quantity. If you do get kind of width, you will get this is kind of length. So get kind of width and get kind of height is the same. And get kind of width is kind of length. And quantity of kind of something is implicitly convertible to any quantity for its tree. So for example, I can the quantity of kind of length is implicitly convertible to width. Because as I said, quantity of being a kind of thing behaves like any of those. This is useful, and I will show you some use cases for this as well, not only for addition, but for other things as well. Quantities of different kinds can be compared or subtracted or added in the library. So first of all, we are right now moving to units, right? In the SI system, it explicitly says that SI system is built on top of ISQ. So this is what we do. We're saying this is second meter gram, but not any second meter gram. This is second meter gram based on the ISQ length, mass, and time, right? So this is what I express here with kind of time, kind of length, kind of mass. I said that meter is used to express any length that we have in the system. So this is for the first use case for kind ofs. And this is actually what makes those two not compile if you want to add two different things. And direct name units are similar. I can also constrain some of them, like hertz, to say this is kind of frequency. So it is not any 1 per second. It is only this 1 per second that is a frequency, not modulation rate, not frequency, and this prevents this addition on different quantity types. Right? And again, notice, all of the arguments here are NTTPs. All of this would be impossible to write before C++20. And notice how easy it is to make to specify and use. C++20 is awesome and provided a lot of new, really attractive, really exciting possibilities for the programmers. Actually, 3 years ago on this conference in 2020, I said that usage of class templates of class types as non-type template parameters might be one of the most significant C++ improvements in template metaprogramming during last decade. At this point, I even didn't start writing this V2 version. I didn't know actually that my library will be using those as much. I just predicted that it might be the case, and actually in my library it is a huge game changer. If something behaves like a value, probably it should be a value as a parameter type. Don't do stud ratio anymore. We can do better right now. In C++20, right? Of course, Howard couldn't do better because, well, C++11 was the base then. And Chrono is great, but don't get me wrong. Unit symbols. The symbols introduce a lot of short names to the scope. That's why they are opt-in in separate namespace. If you want them, you have to opt in, get this namespace explicitly, because otherwise you may have a lot of collisions with your identifiers. Right? Also, notice that there are two new actually that were added in November last year. Two here and two here, so total 4. But also I highlighted 8 of them. All of those 8 are not supported by stud ratio. You cannot express those with stud ratio in any compiler right now. Because int64 is not enough to express this ratio. That's why we had to provide some alternative, something better for the library to work. That's why we are not using stud ratio, not only because it's not NTTP, but also because it doesn't scale enough. All right, so finally, we talked about quantity specs, we talked about units. Now you can talk what is a quantity. Quantity, according to ISO standard, is a property of phenomenon, body of substance, where the property has a magnitude that can be expressed as a number and a reference. And it says later on that reference can be a measurement unit. So a quantity is a number and a reference, and this is what is expressed in the primary template. Reference being an NTTP, and representation type that is a type for the number. So I expose a reference to the user. I have a number. Notice that it's a public member. And this is public member because it has to be a structural type. I hate it for it. I hate rules for structural types in the C++20 language. I hope it will improve. If you are interested in that, please contact me. I will help you. We can work together to make it work. Because forcing us to write incorrect code just to pass it to a template is wrong. But I want to pass it as a template parameter for other things. You will see some examples later on. That's why it has to be a public member, and I hate it. And then I have a number function, because quantity is a reference as a number. So I get the number in all of the ways, and I also have number in specific unit to make it type safe. And safer to use, right? And again, concepts are awesome. Concepts are everywhere in my library. If you don't have experience with concepts, you should try them. They are really, really great abstraction, provides you totally new opportunities that you ever couldn't do even with Svine and other tricks. So how you can create a quantity? You can create a quantity either by definition, specifying quantity of meter, or using the symbol, or by multiplied syntax. This creates a double instance, this creates an int one, or with the simple as well. With the mixed one, where you specify this one and then explicitly the type, of course, right? Or this way, with some scaled stuff. You can easily scale some things as well. Why we are not providing a quantity that takes a number? Again, thank you, Lisa. Right? This was brought by Lisa a long time ago on the ISO committee meeting. I think it was in Kona, but a long time ago. And we discussed this thing. This is one of those cases. I have struct x. I have vector of milliseconds, because this is again coming back to chrono, right? And I have x vector and place back 42. Nice, works, right? But then, this is today, but maybe tomorrow someone will refactor your type to be microseconds. 42 remains here, compiles fine. User, the guy that is doing refactoring doesn't find all of the instances where it's initialized, because, well, it's not obvious that it is a value being a duration, and you have a bug in your software. Too easy to make a bug. That's why we are not providing this one. Explicit is not explicit enough in the C++ language. So in V2, there is no constructor taking this one. Everything has to be provided with this multiply thing, providing always a unit that you want to work with. So I was talking about like for 15 minutes about quantity spec, but I didn't provide you any example of how quantity spec looked like in the library. So let's see. When actually remember that the definition of meter and second, we're using this kind of quantity spec lev and time. And if I will write 42 times meter, check the quantity spec, actually it will be kind of length. This is what is there. So if you only talk units in the creation of the quantity, you get kind ofs. If I do kilometer per hour, my quantity spec will be kind of ISQ length and ISQ time, not ISQ speed. Because the library will not know that's as a speed. That's just length by time. If you want to make it explicit, you are talking about speeds, you have to do more, you have to be more explicit. So you have to use so-called quantity type aware references, where you specify 42 height in meters, 60 speed in kilometers per hour. And then you end up with correct quantity specs for height and speed. Again, notice how nice the syntax is to specify that. I really like the syntax. I was writing like this in my notebook when I was in the school, primary and then secondary and then university. This is how I spelled those things. When I wanted to write an axis of time in seconds, I always put seconds in the brackets, right? And now you can do the same in C++. Or conversions, right? To a quantity specific type, you can use this way as well. This creates a kind, right? Kind of length, and then you're saying explicitly that it's a height. This also works. This provides exactly the same results as the code above. So it's up to you to specify this one and this one. There is a slight difference what it means, but in the result is the same type. Right? This creates it right away. This one creates the first one kind of and then converts it to height. But this is claimed to be easier to read, right? Height of 42 meters. That's why this one sometimes preferred for readability. So quantity reference can be more than just a unit, right? You can specify 42 meters and then the exact type created by the library is quantity of meter. If you specify this one or this one, you'll end up with quantity reference of height and meter. So this is what this expression creates. This expression is converted to reference height and meter, and this is what you get in the compiler error message later on. But you never have to type height and reference of height and meter by yourself. This is what you type always, either creating a quantity or defining a quantity type. So you never have to type it by yourself. You just by writing this expression, and the type is created for you. Right? And now you may wonder how it works. How it works that when I'm typing this expression, and this is how I defined height, if you remember correctly. Height is just an empty structure, doesn't have any member functions. So how come that bracket operator on height produces a type that uses height? This doesn't have this implementation, so this is the only implementation that knows about height. Quantity spec of length do not know about height. But the operator is provided there. The bracket operator is in this implementation of quantity spec that is not aware of height. So how the result of it uses height. And here comes the C++23 feature. The C++23 feature that is used to implement quantity spec. This is called the implicit or explicit this parameter for functions, right? With this deduction, you can say that this operator provided in quantity spec, so here, deduces what is the instance of this and takes the type as self and then puts this type self in the reference type. So with this, you don't have to use CRTP anymore to specify a type to the base implementation. And of course, the same for the conversion operator, right? So this is the only thing I'm using with C++23, but it doesn't mean that the library requires 23, because if you are below using 20, I have macros that just use CRTP otherwise. So you don't have to use C++23 in order to use this, just use macros, and it's fine, but the final interface is meant to be like this one. Expression templates improve the readability of generated types, right? I already shown you that if you type something like this, this is the result. Direct unit of kilometer per SI hour. Easy to read, easy to understand. If I do something a bit more complicated on typed quantities, stating that I'm having distance by time, I will get this reference type that will say exactly the direct quantity spec of distance per time and direct unit of kilometer per SI hour. A bit longer, but I believe it's still really easy to read, understand, and says exactly what it is, with no overhead. Right? So thanks to expression templates, error messages, and debugging experience is great, much better than no other things that I've seen on the market. And now interesting thing. I've shown you that the standard allows me to create an object of identifier length for a struct identified as length. So I may have a struct length and an object length, and it's fine. But when I have a template called kilo that takes parameter, I cannot create an instance of it called kilo. So unfortunately, for that, I had to use this underscore to say this is type, this is the value. So there's some inconsistencies in the language. It says you can do it for non-templates, but for templates, you cannot do it. Actually, it would be nice to allow that for consistency, and then my library could use exactly the same syntax here and in the error message. But, well, I can deal with that as well, right? As you've seen, it is quite easy to read, but it's nicer to actually have the same thing everywhere. And notice if I was not using this practice anywhere, everywhere here, distance, time, hour, you will see those underscores following the type. To have different type than identifier. And I think that you already are used to that already and you don't want to see those underscores, right? It's just so nice to be using the same name in code and in error message. And just here, this underscores a bit bothers me. And there's also one proposal, P2601, by, among others, the Corentin, being an author, and also other authors there, that could benefit from this change as well. A long time ago, 4 years ago, on ACCU, I said that dimensional analysis is something like this. You can calculate power and do energy per time, and it's in watt or any other unit because those are exactly the same units according to SI. But until now, I was not able to express it in my library. Finally, I can. I can say that power dimension is exactly energy dimension divided by time dimension, so this dimensional only analysis. And then I can also say this is an energy that I just divided, it's a power in watts, right? And those are different units. And I can basically convert with those correct brackets, or I'm considering maybe in member function, like in this unit, as an alternative, to convert this to that. And those are still powers, but expressed in different units. And you can print them, and they will be printed in those units you wanted. But it doesn't make them not being a power. Our other libraries said power is watt. And basically, you cannot choose any unit to represent this power. Here you can, it's up to you. And if you want to get exactly the same answer that I had on the previous slide, you can actually use additional formatting specifiers to get this answer, to have here a dot, just a unit without the value, and to use maybe -3 instead of solidus. It's up to you to specify what format do you want. I have really rich formatting for FMT. And how you can actually implement this, there is a tip, another C+20 feature. This is how I do it. I have a unit symbol formatting structure that provides all of the possible options for formatting, and each of them is an enum with a default. So if you create a default parameter like this one for the argument of the function, you just get default formatting. So FMT with no special flags, right? And then, if you want to actually test it or force specific formatting, you just provide the specific value with dedicated initializer for the aggregates. So you don't have to specify all of them because the defaults do, right? And you just specify the one that you want to modify or more of them and get the result untested. There's another really nice use case for the C++20 feature. So I found out that useful and wanted to share it with you. Another really tricky and a nice thing is that notice that I'm using basic string for static asserts. This is awesome, right? Stud string being compile time friendly, starting from C+20, allows you to static asserts and do all of the tests at compile time for strings, which again was not possible before. In my library, you actually notice that I'm nearly not using unit test framework. I have catch for FMT, but FMT is going to be concept soon, hopefully. It's not yet. Well, FMT is, but not stud format. FMT is already concept. And at this point, I will get rid of catch. I have thousands of static assets in my library. All of the tests are static assets. If it compiles, it works fine. I don't have to run any tests. And it's a really nice approach, because you should test compile time path anyway in your code. So why to do this twice? Coming back to quantity arithmetics, IC 80000 says that mutually comparable quantities are called quantities of the same kind, right? And only those of the same kind can be added or subtracted and compared. So comparisons, width and height works. Subtraction, width plus height is 2 meters, right? Width plus height, if you check quantity spec, actually it is quantity spec of length. Not kind of length, but length, because you were explicit about the types, so you get explicit type as quantity spec. Conversions. For so-called value preserving, I'm following what is in duration right now, right? So we assume that floating point representation is preserving. it might, or there are no overflows in the integral types. This is what Chrono assumes, and I follow this. Of course, it may change after some discussion in SG6 that I plan in Kona. Maybe we will find some better solutions. What does it mean to be value-preserving conversions? But this is current solution. So if you're having a quantity in kilometers, you can always express it in meters, and this is an implicit conversion, value-preserving one, right? Because 5 kilometers can be expressed in meters with no loss of precision, ignoring the overflow possibility. All right, so the same here, right? In implicit conversion, I either to create a type or to print it with different unit. Truncating conversions. If you have a floating point number, 2.5 of meter, if you want to represent this in integral value, you have to use so-called value cast. So I have two different casts, value cast that truncates the value and quantity cast that change the quantity of the object. They are doing something different, so they have different names. Value cast is to change either a type for truncating type or to do unsafe conversion. So if I convert this number of meters to kilometer, I will lose some precision. That's why I'm using value cast. What's interesting is that this one takes a type, this one takes a value, but you don't care, it just works. About quantity type conversions, implicit one. If I have length in a function argument, I can pass height, because every height is a length, it works. If I have height in the function argument and I have length here, I cannot pass length, it will be compile-time error, so I have to convert this explicitly to height. And finally, if I have length as a height as a parameter and I have width as an argument, well, you can remember those trees, width and height were parallel branches, so there is no possibility to convert this either implicitly or explicitly. You have to use quantity cast to pass it as a height, to do some unsafe operation and make it explicit that you're doing something unsafe. I will show you an example, more interesting example in 2 slides, but first let's talk about the first thing, implicit. Implicit conversion from quantity kinds allowed me actually to make such things really easy to understand and really easy to type. Before, when I didn't have those implicit conversions from kinds, when I wanted to initialize this Kalman state being just, let's say, tuple of different strong quantities, or a quantity, an array of quantity of position vectors, I had to specify every place here, like position vector, velocity, acceleration. This was maybe still fine because those were different quantities. But here I have an array of position vectors, and I have to type position vector, position vector, position vector, position vector, position vector, every place here, because it was not implicitly convertible. It was so annoying. And with the fact that I introduced kind-ofs, and kind-of basically behaves as any quantity of the kind, this is implicitly convertible to position vector, so I don't have to repeat position vector in every place here in order to create quantity of specific strong type. It made it much more simpler and easier, and it still works with entire logic because I think it has sense. And you cannot initialize it just with a value, right? Like duration, because it was wrong. I'm talking about the quantity cast, specific quantity cast. For example, if I want to calculate spherical distance, having 2 positions being quantities of degree, and I have earth radius in kilometers, then I use Haverside formula to find something called central angle, and this is the result. Quantity cast of radius times an angle gives you a distance, right? So this is where you actually need to take the radius and convert it to distance. Unsafe operation, but in this case it has sense. Those are use cases for that. Sometimes you want to express one quantity in another having some multiply factor or some angle or whatever. This is how it works, and then this quantity cast is useful, and explicit stating something wrong is done here. Be aware. Another thing that's interesting here is that notice I had to use using directives in order to bring sine, cos to this expression. And those are actually latitude and longitude are specified like this ones. So they are using ISQ parameters inside. So there is an argument being in the ISQ namespace, and still I have to use using directive. What's the reason? Is that ADL, let's say it's broken. And everyone knows it, right? But for this case, actually, it doesn't work. Because ADL in the standard says explicitly that, well, ADL is argument-dependent name lookup. It looks for the identifier in the namespaces of its arguments. And it says explicitly that either we are looking for class template specializations in the namespaces of template arguments for the type parameters only, or for templates as well for the members. And there's even a note in the standard saying that non-type template arguments do not contribute to the set of associated namespaces. So standard is explicitly stating we are ignoring NTTPs in ADL lookup. Right? And actually, before I will show you maybe a bit more about this, first there is a rationale why I need this to be in specific namespace, not just in MP units. Because there are plenty of documents. One of the authors that is the most active in the domain is Paul Quincy. Actually, I'm in contact with him. He provides this abstract. Angles in the SI, a detailed proposal for solving the problem. A recent letter proposed changing the dimensionless status of the radian and steradian within the SI. They want to make it within the SI and also within the ISQ for the degree and the angle to be a strong type and a strong unit. A base dimension and a base quantity base unit for those systems, because it makes a lot of sense to make it like this. And that's why I have also another system, not only SI and ISQ, I have an angular system where angle is a strong dimension and a strong quantity type. Right? So I have angular and then ISQ angle that depends on this. So this is ISQ rewritten for the angular definitions. And then I end up with two different namespaces. I have sign and assign for SI stuff, so ISQ based quantities, and for angular quantities. Maybe sign could be put in the same namespace because they are different by argument name. They have different types here, so they could be put in the same namespace and still found during overall resolution process. But the problem is Arcus Sinus, because Arcus Sinus is using the same argument, dimensionless and dimensionless as an input. And they have different outputs. So it will be a not valid definition if they will be put in the same namespace. And that's why I had to put them in separate namespaces. But then the ADL doesn't work. I believe that ADL rules are incomplete. It was fine before C+20 maybe. But with C+20 we have new possibilities, exciting possibilities to use NTTPs in different ways, as you see, for example, on this library. But I believe there are many other use cases for that. And ADL will not work for them. So you can either write this way, which is really user-friendly and nice syntax, and ADL doesn't work. Or you can write it this way, and then ADL works. But that's not what you want to type. Right? So C++ often does not allow us to have nice things, right? We cannot actually easily change it because it will be a breaking change right now. Because even before C+20, if someone had a structure X in a namespace my and provided a pointer to it because it was allowed, or a reference in a class template parameter, or had an enumeration in the namespace my and used enumeration as a parameter, those namespaces were not involved in the ADL lookup before C+20. And with C+20, we of course extended those rules and not changed those definitions. So I think there's no chance to fix it in the standard. Unless you have some ideas, please let me know. We can work together on this problem. But I believe that we have to wait for epochs, and hopefully that will happen in the language. Because if you have epochs, we can fix everything, or a lot of things. So this is one more possible proof that epochs are useful and could help with usability of actual products. All right, so let's see this strong interfaces example that I showed you before. This is how you write it in this library. You have box, and now you specify exactly horizontal length, width, and height. And you have horizontal area, right? So there is no ambiguity. Of course, a user can choose either not care about that, because it's up to you. You can use kinds. But if you actually care, and you write either this syntax or this syntax, there will be a compile time error if you do it wrong. Right? And this is the target here. This is the intention. Also, you can write generating interfaces with quantity of concept, saying, I don't care what is the exact quantity as long as it is a length, or is it a time, and the result should be speed. And then I can pass kilometers, hours, miles, hour, minutes, and is as efficient as just dividing doubles, and then of course the output will also be printed in those units, not always converted to meters and back possibly or not. Right? So no additional conversions, no additional operations, no overhead at runtime, just working on just dividing the values you provided and making sure that dimensional analysis is correct and preserving the units provided by the user. The library can also provide custom representation types, like the measurement. Measurement is either a value or an uncertainty, both of them. Two things at once, right? Because you measured something with a measurement error, so this is what you want to express. You can use a class like this one. And then if you write a measurement of 123 meters with accuracy of 1, this is what you get. After multiplying it by 10, also the error is multiplied by 10, right? This is how it works. Or you can do something more complicated with acceleration. This also works. Another possible use case for custom representation types are linear algebra types. You can use linear algebra vector, specifying this is a vector times meter, right? And then you are playing with linear algebra. But the question is, what should be the result of that? As you know, this library takes this one as a representation type and tries to create quantity of this value with meter. But if you go into the linear algebra operators, you will find out what the other library is doing. It says if one of the arguments is my type, so a vector, and my representation type can be multiplied with the other thing, probably scalar, like times 2, then the result will be a vector multiplied by 2. Notice that there is 2, not meter. Right? If there is 2, not meter, you will expect this to be a vector of 2, 4, 6. Right? This is how LA works. And you have collision of operators. I want to make it a quantity wrapping the vector, and the linear algebra wants to make just a scaled vector from this. So in this case, you may have some overload resolution ambiguity for this operator. So this is where you actually may use a factorial function, make quantity, to actually override it. Or you have to provide a custom dedicated overload saying wherever you want to multiply a vector by a representation type, this is what you do. Right? So write a new operator over them to specifying specific rules for these specific types of arguments. Coming back to our measurement class, I can initialize the member value on the constructor initializer list, but I can't do it for uncertainty, which also bothers me because I always say on my trainings to the students, always keep the brackets here empty in the constructor if only possible. Use constructor initializer list to initialize a value in a class. This should be empty. But I can't because I have to use ABS. And I don't know what's a representation type. It may be a linear algebra vector, whatever. So I cannot just put std ABS because it's just for floating point numbers and integrals. I have to use ADL. And I cannot use ADL on the constructor initializer list. That's limiting. Another possibility is when I actually want to implement this ABS, I want to check this ABS should be allowed only if this compiles, right? So actually I have to provide two concepts here, two constraints, checking either through ADL or from std ABS, which sucks again, because I cannot do ADL here, again. So maybe this is one of the reasons why we should think about customization point objects for mathematical functions. Because plenty of users right now work on numeric safe types, for example, or SIMD, or other wrappers for numeric types. And all of them will support some kind of those functions. And having to type code like this, it's really problematic. With CPO, you will not have those issues, right? Maybe you should consider that as well, as an extension to the language. And finally, probably the last feature before we finish, affine spaces. We can use with affine types in our language, which means with quantity and quantity points, like duration and time point in Chrono library. Actually, we are going to have an example of this today on the lightning talk, so please come. I will show some another exciting engineering issue that we had in our history about actually affine types. So min C level can be defined as absolute point origin for height, called min C level. And then I can say I have two quantity points of height measured from min C level, and I will have Zurich ground level, the airport, and my home airport Gdańsk at this height, this altitude, right? So I have two altitudes for two different airports. And then I can define even more. I can define other points for the altitude over those airports. Notice that with NTTP, I can pass this quantity point type as a template parameter value to this type. That's why I needed those structural types. Because I want to pass quantities to quantities. Right? I defined one quantity point using another definition of quantity point as a reference point. And this also makes really awesome because I can write things like this one. I can say, well, this one, Zurich, relative to the ground level is this one, but absolute value, so starting from the beginning, from mean sea level, is that one, right? I can compare and subtract the altitudes. I can subtract the ground levels, or even altitudes and ground levels, and everything works fine, and type safe. Oh, and this is the last feature, I think. Faster than light speed constants. This is a new feature in the library that I actually was really proud of because actually one of the users suggested this one, but I found out how to implement this and I was so proud of myself that I invented how to implement this because no one ever did it in the C++ domain. Then I actually started to check Python and Java, they both have it. But I invented this by myself, I promise. So, standard gravity. Standard gravity is a constant, right? It's a physical constant, but we implement this as a unit. We implement this as a unit and specify the symbol for it, being the symbol of gravity, and ratio for it in meters square per square seconds. Right? And then if you want to have G, I type in just one standard gravity, or one speed of light, 1c, right? This is how it works. And what's interesting, if I actually have some code, it's some storage stack example in my library, but it's not that important what it does, but it has two functions. Field weight. Weight is a force, not mass. This is important, right? So the return is weight, mass times g. And then I have field level that has height, measured mass, g times divided by field weight, so this one. If you're writing this in your notebook in the university, what you will do with G or C, you'll just strike it out. And you want the compiler to do the same. You don't want to pay for this operation at runtime. You don't want to lose precision because of this ratio. You just want to strike it out if it's possible. And this is what this intention of it is, right? If I actually will try to take those values and print them, this is what I get. The field weight is printed in 100 g kilograms. This is the default unit. Of course, I can specify explicitly. I want to have it in newtons, and then you have it in newtons, and then you pay for the runtime conversion and for the precision loss, right? But until then, it's just g kilograms. And actually, if I'm writing the other one, field level, there was never g involved, and it's exactly 20 with no floating point precision issue, because g was just struck out during compile time, the same as second or meter would be, because it's just a unit. So it's faster, safer, provides better accuracy, a really nice feature that I'm really proud of, that I invented this by myself. Although not the first one, as it turns out. So as a summary, the new library I really feel is simpler because we don't have downcasting facility, CRTP idioms, we don't have user-facing abstractions that are no longer needed, like exponent, prefix, quantity kind, quantity point kind, all of this is gone. We have one named unit and one quantity specs for everything, thanks to concepts. So you don't have to remember like 10 different names for units or quantity specs to define them. Much tertiary system definition. It's really simple right now. There is just only this amount of definition that is really needed. If you see how terse SI is definition, it's like, I don't know, 30 lines or whatever. ISQ definitions are not templates anymore, so you can do this specific dimensional analysis by itself. So it's also better, not only simple. It has composable units. Consistent NTTP usage improves readability and usability. We use expression templates to have better expressions, better types in error messages. We can do pure dimensional analysis. We can have much better quantity creation. I don't have anymore like 5 ways to do it, or many other issues connected to this. I don't have to ask the audience which one do you prefer. right, as it was before. Quantity spec improves the definitions. We support all ISQ quantities. We have quantity kind support, faster the lightning constants, and much more that I even didn't have time to talk about today. So this is about the library, but also about the C++ language. C++ is awesome. You cannot do that in any other programming language in the world. C++ is the only language that allows you to do that. With this safety, with this speed, with those abstractions. Right? It's done thanks to templates, concepts, NTTPs, deducing this. All of those are great features. With every new C++ language version, we got new exciting features that allow us to provide better abstractions for the users. We are not providing, as an ISO committee, standards in 3 years to make our users suffer even more, or to chase the standard all the time. We want you to have better abstractions, and this is our purpose, right? We don't want to make you suffer, I promise. So please migrate to C+20 if only you can, because it's so amazing. But this doesn't mean that there is no place for improvement. There is. So this is my wish list, right? Get rid of these artificial limitations for structural types, because I hate that the member is public in my quantity class. This is insane, right? ADL rules are not updated for NTTPs, and it will hit us in many places. For example, right now we are talking about integral constant, a new version, upgraded integral constant, and it has 2 parameters, NTTP and then decal type of NTTP value, just to enable ADL for it. So it has 2 parameters instead of 1 in order to enable the ADL, and this sucks. I don't want to do it here because I want to have type brief. I don't want to repeat the same times twice just to make ADL work. CPOs for maths, something that may be useful, because I expect that in the next like 5-10 years, we have plenty of mathematical wrappers that provide either safety or functionality to underlying systems, because we know that underlying C-style system is not safe. It was brought by so many people. And those CPOs may be really useful in order to then make it much easier to work with them. And finally, this inconsistency between naming that doesn't allow me to have class template and its instance of the same name could be also a potential thing to solve, and will also help Corentin in his paper in order to make this feature possible to implement without any issues. And with that, I am done. Thank you very much, and I open for questions.